Good afternoon, everyone, and welcome to the second instalment of Big Data London's Modern Data Architecture webinar series. This one's centering on data warehousing. So I'm Andy Steed, I'm Content Director of Big Data London, and I'm joined today by Mike Ferguson, give us a wave, Mike, and Rafael Massei. Hi, Rafael. Yeah, so I mentioned it's episode 2. Episode 1 and episode 3, if you look at the attachments in the bottom left-hand corner of your screen, you can view episode 1 on demand. That was on data integration. And episode 3 is coming up on the 18th of May. That's on data visualization, and that's at 2 p.m. on the 18th. There's details there of how to register in the attachments. So back to today. This session is designed to be interactive, obviously, so please send your questions in. I'll put them to the presenters after they've finished. But enough about that. I'll pass over to our first presenter. Over to you, Mike. Thanks, Mike.
Thanks, Andy. So good afternoon, everyone, or good evening, or good morning, even wherever you may be. So I'll just share my slides here. So okay, so my session is I want to start off just to kind of look at what's happening in regards to data warehousing, particularly around the cloud computing environment. And so what I want to talk to you about is, the traditional data warehouse, something that's been around now for over 25 years. Look at how digitalization has kind of impacted on data warehousing, the new data that's coming around as a result of that, and the kind of problems, I guess, that's caused in terms of data warehouses, and why, therefore, they need modernizing, and how cloud data warehousing is part of that modernization strategy, and how a combination of cloud data warehouse and data lake has all of a sudden become quite a close-knit area in that modernization approach. How you can look at scalable ELT processing in a cloud-based data lake environment to prepare data for a warehouse, and then how you can effectively extend data warehousing to become more modern on the cloud with the integration of streaming data, data lake for this kind of real-time data warehousing in a cloud computing environment, how we can handle complex data in that environment, and also integrate with things like data science and self-service BI for richer insights on the back of that. So if we go to this chart, which is just a classic data warehouse kind of architecture, which has been around for a very long time, very stable environment. Probably the last major change to this was probably around about 2010, where mobile BI on the right-hand side probably was the latest addition to this kind of world. So obviously in this environment, nothing much changed there. But when we see the adoption of digitization in many organizations, what we're seeing now is a whole bunch of change with the digital transformation program, affecting both operational and analytical systems. And in fairness, most of those changes are now playing out in what I would call a hybrid computing environment. That is both on premises in the data center, but increasingly now on one or multiple clouds. Large enterprises now definitely into a multi-cloud hybrid computing environment beyond just their data center, and even all the way out to the edge. Now, if you look at how that would impact on any business, as you can see here, you've got a kind of classic kind of business with suppliers on the one side, and a supply chain with a back office of finance and procurement and HR. At the other end, we've got customers with a front office of sales, marketing, and service, and some kind of products or services that you sell into the marketplace. With regards to digitalization, what we're seeing is cloud adoption, which I've already mentioned a moment ago. We're seeing the adoption of mobile devices to connect both customers, employees, and suppliers to enterprise applications. And so there's a need to mobilize, if you like, or make enterprise applications mobile ready. We've just seen an explosion of APIs around applications in order to make that possible, and the adoption of cloud computing. Social networks emerging, and so companies having to go there with things like corporate Facebook pages and Instagram and whatnot. And Twitter accounts are all trying to go where their customers are congregating. And of course, things which are being deployed both from an industrial perspective, perhaps in production lines and out in different aspects of business operations, whether those are distribution chains or supply chains or oil and gas or fields or even in everyday hospitals and things like that. And consumer IoT, which of course are things that you may wear, like your watches on your wrist or your mobile phone in your pocket, and various other kinds of wearables. And of course, another part is increasing automation through business-to-business process integration to kind of reduce the number of people involved as part of that. All of that digital transformation is causing an explosion of new data. I spoke about this in the first series of the series. Master data and transaction data, which is at the top, would be the classic data feeds into a data warehouse. But now we have machine data in the form of things like clickstream, that every click that people do on your website recorded. It could be sensor data from these industrial or consumer IoT devices. We've got human-generated data, such as opinions on social networks, inbound emails, voice data coming in. We've got external data coming in from open government websites and the like. And so what we've now got in most organizations is some kind of analytical ecosystem consisting of multiple systems, of which the data warehouse is just one of those. And so other analytical workloads happening beyond the data warehouse around it. And so there's a huge desire now to integrate the data warehouse with these other analytical workloads and systems in order to get a deeper, more integrated picture of the insights being produced across that ecosystem. And of course, this whole thing is now available on the cloud. Or for most of us, probably we've got some of it in the cloud and some of it in our data centers. But if I look at the way a lot of people have focused on building these different analytical systems that I mentioned a moment ago, they've been very silo-oriented. And I've already cited in the first of the series, that there's a lot of companies buying multiple different tools to do the same kind of data integration job in each one of these different silos, and there's a lot of technology overspend happening there as a result, and there's not much in the way of metadata exchange between them, so that people using one tool can't see what's going on in another. But if I was to pick on a particular silo, in this case data warehousing, there's no question, having been the first white paper on data warehousing, I think, was in 1988. So we're talking over 30 years, and some of these systems are 10 or 15 years old in some cases, and certainly in need of modernization. So an example of this might be with existing data warehouse architectures, the number of data stores. So, you extract from sources, you put it into an operational data store, you take it out of there, you clean it up and integrate it, you put it into a data warehouse. Maybe that's ELT processing by loading into staging areas first and then transforming from there into production tables in your warehouse. Then you extract subsets out of that again, you put them into data marts, and finally a business user gets their hands on the data. So anything happening back in those operational systems can take quite a while to reach the business user. And so for me, there's too many copies of data as well between all of these systems, and the opportunity to therefore see inconsistency emerge as a result of it. In addition, if you take something like streaming data, where does that fit in that classic architecture? I mean, if I was to put streaming data into staging, how could you deal with real-time data? I mean, in my opinion, that just takes too long for people with a BI tool to see that data in order to be able to respond in a timely manner. And so becoming real-time data warehousing with this kind of classic architecture isn't really going to work, in my opinion. So it needs modernizing to be able to accommodate that. Not only that, what about a change? If you make a simple schema change to a data warehouse, it could affect the ETL jobs feeding the data warehouse on the left-hand side of that data warehouse disk there, or it could be on the right-hand side, could affect downstream ETL jobs and data marts and even semantic layers in various BI tools as a result of that. What if I happen to add a new data source? It could go all the way down that line, affecting everything, all the ETL jobs at each stage, each data store, schemas, semantic layers in BI tools and whatnot, or a schema change in a data source, same thing. So the problem here is this waterfall approach to building data warehouses, can have a real domino impact if any kind of change happens. And so the length of time to test it and get a new change into development is really much longer than it should be. There's not enough agility in this kind of architecture. Not only that, but with the mobile devices that I mentioned a moment ago now being connected into enterprise applications, the rate of transactions has skyrocketed. Customers, for example, doing their own transactions on mobile banking. That's resulted in a massive growth in transactional data flowing into staging areas in data warehouses. And that can cause upgrades in the data center, having to upgrade to take much bigger staging areas if you're doing ELT processing on a data warehouse in your data center. And that's a sort of headache that CIOs are dealing with at the moment. They'd rather not have to do that, would like to perhaps offload that somewhere. And then we've got all this other new data coming in. What is it? What happens if it's semi-structured like JSON or XML data or Avro data? There's enormous volumes of it. Clickstream would be a good example of that. And in some cases, it could be unstructured. How can you store and process that and integrate that with what you have already in your data warehouse in order to take advantage of a more complete set of information? And how do you deal with data science in a data warehouse? When data scientists are off using different tools, perhaps on cloud, building predictive models outside of the world of traditional warehousing and traditional BI, how do we integrate that? To take advantage of those models and leverage them within the context of BI tools accessing data warehouses. These are challenges that we all face. And one of the other aspects clearly in modernization is migration or is data warehousing in the cloud. All kinds of drivers for that, things like improved data security in the cloud. Many cloud providers now have very, very secure environments. Improve customer service, that you can cope with much larger volumes of data, getting ability to scale that out, only paying for what you use in that environment, and so switching away from capital expenditure to operational expenditure, and being able to take advantage of these kind of low admin, because cloud providers are often providing that capability for you. Much more scalable kinds of capabilities at relatively low cost and more agility coming from it. And just to give you an idea, from the Fourth Industrial Revolution survey report, which comes out at Big Data London every year, I wrote the full report for this, and you can see some pretty amazing results. Back in November, which showed for over 500 500 enterprises surveyed, 42.4% of them were already migrating their data warehouses to the cloud, and over 35% said that by 2022 they would have between 40 and 60 of their entire analytical workload all running in a cloud computing environment. So pretty major move here to the cloud. And I think, data warehouse modernization and adoption of cloud is resulting, therefore, in a hybrid world. Most of my clients have got multiple data warehouses. It's not just they've got one and they're migrating it. It's that they could have multiple, and perhaps they're either migrating it or if it's really old, maybe rebuilding it in a cloud computing environment. And so, accessing this data from BI tools means that the business user may need to access data warehouse in a data center, or a data warehouse in the cloud, or even both. And so, cloud storage is typically the kind of storage that's underpinning these kinds of analytical systems in the cloud, but whether it be things like Hadoop or graph databases or data warehouses in this particular case. But it's this connection, if you like, between data warehouses and data lake, where cloud storage is being looked upon as a centralized data lake to load all kinds of data into, where we're seeing deeper integration emerging. And just to back that up, I mean, again, looking at the Fourth Industrial Revolution survey, I asked the question, what is it that you're planning to use in 2020? And number one was data lakes. So, it's pretty clear that the interest in data lakes is very high here. And we spoke in the last seminar, the last webinar in the series, the first one we did, which was sponsored by Fivetran, that people are using data lakes as a way to organize data, ingesting it in and preparing it and producing ready-made data that can be consumed around the enterprise. And of course, the data warehouse happens to be one of those consumers. And so loading or bringing this data into a cloud storage-oriented data lake and using software to do scalable ELT processing on the cloud, to take that raw data and produce trusted integrated data for supply into data warehouse and other analytical systems, either to make it available to data scientists or even into graph databases or even into MDM systems, is becoming a kind of common approach. So we saw that this kind of modern architecture emerging of, ingesting everything into, say, data lakes, including streaming data, producing ready-made trusted assets that can be consumed by data warehouse and other use cases. And so the cloud-oriented data lake, if you like, becomes a zoned environment where we can ingest raw data in one end of it from a range of structured and semi-structured and unstructured data sources, even streaming data sources like IoT, for example. Prepare that data and make it available in a trusted data zone, which is effectively cloud storage underpinning the data warehouse. And so therefore becomes very easy to get consistent data to a range of analytical data stores so that everybody's singing off of a consistent a base, if you like. And we can simplify access to that through other technologies as well, including data virtualization. So real-time data warehousing all of a sudden becomes pretty, relatively straightforward to do here. For example, I could stream the data straight into data lake storage, perhaps an event store on data lake storage, and then point external tables within the data warehouse directly to that, so I can just query that data as it lands. Alternatively, I could ingest the data from there into a data warehouse table and start to access it that way, and give that data both to business analysts with self-service BI tools or to data scientists if needs be. But the key point is that by having deeper integration between data warehouse and data lake, I'm able to see streaming data pretty well as soon as it arrives and be able to query it and act upon it, and therefore achieve this desired state of real-time data warehousing. In addition, with things like more complex data like JSON, for example, which is very popular these days, again, I could have that data on a data lake and then ingest that data into a data type within a data warehouse, depending upon it. In the case of our sponsor today, Snowflake, a variant data type where I could then take that JSON data and then put a view over the top of it so that I could see that data as if it was just in a tabular format and start querying it. Very, very easy to do. And of course, I could then even make that data available again to data scientists through a SQL mechanism or a data frame from a notebook. And of course, elasticity on the cloud matters so that you can spin up different compute clusters because storage could be separated from compute. In this case, as you can see here, a kind of architecture of Snowflake. As you can see, I can create these compute clusters that I've got on the right-hand side. On the left-hand side, these are called virtual warehouses. So I can kind of decide the size of it, and then you can see where I can specify that I can use a particular virtual warehouse and then run a query so that it runs in that compute environment. In this kind of environment, you really need the cache to deliver the performance in order to give you the parallel computing capabilities. That becomes critical there. And so also deeper integration with self-service BI tools and data science as we start to see the ability to run Spark closer to the data warehouse itself, and to potentially connect BI tools to things like Spark SQL or Jupyter notebooks to Spark SQL, which could then, in data that's retrieved from your data warehouse could then be made available to do machine learning on it directly from within a Jupyter notebook, for example. Alternatively, there's a strong likelihood that advanced analytics like predictive models could be deployed in the data warehouse, and so multiple BI tools could then access that data and get the consistent predictions from any tool or applications accessing it. And so there is also a trend here to develop and deploy analytics close to the data, because as the data gets larger, we want the ability to deploy trained models. Maybe we develop them offline in a sandbox, but then to deploy them into things like a data warehouse or into streaming in environments in order to take advantage of those trained models. And so therefore, that when BI tools invoke those models, the cloud-based analytical warehouses allow us to then run the analytics close to the data. This is what I would refer to as what I would call push-down execution. And then, from there, obviously, what that gives us then is a whole range of ways in which we can modernize a data warehouse. So I think what's clear, looking at my clients at least, is many of those organizations have got data warehousing systems that have started to fall behind the kind of business requirements that are springing up as a result of the digital transformation initiatives going on in organizations, with so much new data being created and desire now to become more real-time, being able to leverage advanced analytics, even with data warehousing data, and to be able to take historical structured data in data warehouses and combine it with things like streaming data or more complex semi-structured data like JSON in order to be able to give us deeper insights. So this requirement to support this new data, to become more real-time, to be able to operate at a lower cost and still scale, to be much more easily able to change. All of these are all key requirements. As far as what companies need to do about this, well, they obviously have to look at, well, what is it that your business wants? What kind of prioritization would put onto these kind of requirements? And then look to upgrade or migrate your existing data warehouses to be able to embrace things like change, to be able to process more data or to add in more complex data types. and to give you more timely insights on lower latency data in a modern, perhaps cloud computing oriented data warehousing environment. So that, and then ultimately on the back of that, hopefully make those insights actionable in order to shorten the time to value through automation and alerting and various other actions, which we'll look more at in the third webinar in this series coming up next week. So with that, I hope that's given you an idea of some of the things that you could potentially do with a data warehouse in a cloud computing environment. And with that, I'll hand back over to Andy and Rafael.
Questions now, Mike, if that's okay, and then I'll defer the rest of the questions until after we've heard from Rafael. So firstly, what sort of things do you need to consider when migrating data warehouse to the cloud? I guess that's some tips or something, perhaps. Have you got any tips?
Yeah, there's no question. There's a lot of things to think about. Some of these systems can go back 5, 10, 15 years, so have built up a lot of baggage, so to speak, when migrating. So I think you have to break the data warehouse migration down. One thing you're going to have to do is you're really going to have to do a massive assessment, I think, of your data warehousing, existing data warehouse system to really understand what's in there. And then you're going to have to start looking at, breaking this down. I've got to migrate the schema. I've got to migrate the data. I've got to migrate the users and the groups and all the privileges associated with all of that. I've got to figure out, how do I get my data out of my existing underlying system? And in some cases that could be compressed. So when you take it out, guess what? It goes woof. And so a bit like popcorn, so you're going to have to be able to accommodate that and be able to move it to a cloud computing environment. In some cases that may mean physically moving it. In other cases, you may be able to move it over a public internet or private network connection if security is a big deal for you. So I think you also need to worry about if you're going to change your database, you need to worry about the schema. If the database is being changed from, let's say, a legacy database environment that you don't want to continue with to a new one, you have to think about SQL differences and all of those, and highlight and figure out what all of those are so that you can understand this. And one thing I would say is, one thing you don't want to do is you don't want to start redesigning your data warehouse in the middle of a migration. You got to take a strategy that allows you to prove what you've migrated is giving you the results you had when you were running in your original environment. You want to do that with really low risk. So for me, I'm more of a lift and shift fan on a migration, and then modernize it rather than attempting to modernize it during the migration, which to me is just way too risky.
Yes, yeah, and I'm just going to push a couple of questions together here.
Okay,
we've had loads of questions, so thanks so much for everybody for sending them in. How can we improve agility in data warehousing? So, how are we going to? Is there any tips you've got in that?
Yeah, I think there's a couple of things you can do there. Obviously, agility comes in a number of ways, and we've talked about having elastic scalability and those kinds of things already in my presentation. But you can have agility in design. A good example of that being what I said with there's especially in Europe, a data modeling technique called Data Vault, which was actually invented by Dan Linstead, an American, but it seems to be that Europe's the hotbed for Data Vault these days. It's spreading around the world, but that's more of a component-based development approach to data warehouse data modeling. It's not for data marts, however. It is for data warehouses. And without a doubt, that can help a lot and it embraces change, allow you to make changes pretty easily with pretty low impact. Another thing you can do, because one of the side effects of Data Vault is it gives you more tables, and so sometimes you end up with a demand for more data marts as a result, because it's too hard to navigate the Data Vault data warehouse. So you can do things like virtual data marts to reduce the number of data stores there. It gives you more agility on the marts as well as agility on the data warehouse. There's a number of things you can do, but that's a couple of them. And I also mentioned the modern architecture where you can build these ready-made data assets to speed up your ability to add new data and build these things. So there's a range of things you can do there, as well as, of course, the more automated things like elastic scalability and all that's taken care of by cloud-based data warehousing systems.
Perfect. So I think that people might not have heard my first question, which was things you can do to improve agility and data warehousing. We heard the answer. Fine. Thank you, Mike.
All right.
So sorry about that. Sorry about that, everyone. And like I said, we've got tons and tons of questions. We'll come back to them once we've heard from Rafael. Just to answer a couple of the easier questions, in terms of slides and stuff from this presentation, you might want to think about watching it on demand. It comes on demand as soon as the session is over, and you can watch it again with the words and sort of skip to the bits that you're most interested in, if that helps. So I'd like to pass on now to Rafael, who's coming with his presentation. Over to you, Rafael. Thank you.
Thank you, Mike, for your presentation. Good afternoon, everyone. Let me just share my screen here. My name is Rafael. I'm the EMEA marketing manager. I joined Snowflake 1 year ago, and it's unbelievable to see the types of things that our customers have accomplished with Snowflake so far. In fact, I'll tell you about one of our most successful customers at the end of the presentation. I'll also show you our journey so far in our product. In the past few years, we've seen the proliferation of new technologies such as mobile and big data. And to support this realization, now customers require a platform to fully leverage all their data. And it's the reason why so many customers are migrating to the cloud. Earlier this year, we got almost $500 million in additional funding from Salesforce. This is really our momentum. We are expanding rapidly around the globe, and we just launched the Snowflake Data Exchange that will break down data barriers between data providers and data consumers in the public marketplace, and I'll talk about that later as well. And most importantly, it's very cool to see how Snowflake is growing so fast. We have over 3,400 customers and retaining customers that we already had. And I mean, before talking about our journey, let's level set on the current state of data and the opportunity that it presents. We all know that data is already one of the world's most valuable resources. Even The Economist said that a few years ago in 2017. So it's fair to say that data is one of the most important things for companies. As you can see there, as Mary Meeker said, the rapid rise of gathered and analyzed digital data is often core to the holistic success of the fastest growing and most successful companies of our time around the world. That said, I can now talk about the new technology trends and say that the recent changes in technology, they are changing the way we work with data. It is making it easier for us to turn it into an actual asset for the business. So first, on the left, the rise of the cloud. And unlike any traditional platforms that were built with all the scarcity of resources in mind, the cloud offers actually unlimited capacity for us to store and process data. That gives us the opportunity to run a very high number of workloads at a really, really high performance in one single platform. So you can see there on the left how the cloud gives us the ability to scale and centralize data. Second, the explosion of data. that is growing in both size and variety. And we know that data means insights, but we need to be able to access it. So the second topic is explosion of data in IoT, mobile, and social open up new opportunities for insights. Finally, the diversification of analytics. When, where, and how we do analytics have completely been transformed. So everyone needs to analyze data now. And it's becoming the central part of everyone's job in most of the companies. We need to know what is happening and when to predict what may happen and to make the best decisions. So analytics is growing in importance everywhere and for everyone, as I wrote there. But for you to take advantage of your data completely and at the same time create significant impact, you need a new approach. You can't just follow what you were doing before. So first, when you're able to get your arms around all of your data, it's much easier to make better, quicker business decisions. So centralizing data into a single platform is vital. By reducing the wait time for data, we get all the users from your company and all the data they need whenever they need it. As a result, you're going to see a lot of new business opportunities, and I'm going to talk about this later as well. The second topic is the ease of use and flexibility that comes with working with data in a new way that will allow us to reduce the overall cost of how we scale data management and analytics. When we create a single place for all types of data, we are finally able to deliver while planning for scale. And again, without adding all the high costs that you used to see in the traditional architectures that also required a lot of overhead to build and maintain. So second topic, reduce the cost of scaling, data management and analytics. And then third, when we're able to better access all of the data at a lower cost, we can finally focus on delivering a great customer experience. We can improve how we interact with customers. And we can improve how we build better quality products and how we make data more accessible. So we can actually focus on creating a great customer experience with data when we capitalize on the new trends. So we get users all the data they need, leverage a single place for all types of data, and ensure that everyone, internal and external customers, can easily leverage data to get their jobs done. That said, you can't use yesterday's technology to do that. And you can't, and definitely not tomorrow. So to fully take advantage of this opportunity, we created the first cloud data platform. We can deliver the performance, the scalability, and the concurrency required. As you can see here, if we start on the left, over time, many technologies, they have tried to tap into this opportunity, but none has fully delivered to meet the ease of use, scale, and performance needed to support today's workloads. So for decades now, on-prem enterprise data warehouse, they have done an okay job on delivering the performance that we need to analyze structured data. And at the same time, they were relatively easy to use. So they grew in adoption fast. But as the dynamics of data and analytics evolved, it was very difficult to support concurrent workloads. And as you can see here, not all users could access the data they needed. Then first generation cloud data warehouse came and they helped to some extent. They offered elasticity and better cost performance that the on-prem alternatives. But given that they were all cloud-based versions of their on-prem data warehouses, they were still limited in their ability to handle all data for all users. Enterprise data warehouses, they can't support all data or users because they were designed as a single cluster system in a time where before we had dozens of workloads for them to run. So moving enterprise data warehouse to the cloud made management easier, but didn't fundamentally solve the problem because it was just still a single cluster system after all. So then Hadoop and data lake object stores, they solved part of the problem by making it possible now we could handle both structured and semi-structured data, but they only partially address the problem of getting many users on the platform, as they're very, very complex and difficult to use, and they're limited in their performance. So now, one of the main issues was that Hadoop wasn't designed for SQL, and that increased difficulties significantly. So a cloud data platform is the first solution that brings the best of the on-prem enterprise data warehouses, the cloud, and big data into one single platform that delivers the scale, performance, and concurrency that others couldn't. So here is a traditional data architecture than some of that we see all the time at Snowflake. So most organizations we work with are limited in their ability to use and capitalize data, because they're supported by an architecture that you can, as you can see here, that is costly and complex. They're normally how can I say, a complex web of technologies that are just glued together to deliver data from left to right here. So from raw source to its intended destination. And across the integration, the transformation, the aggregation, and the delivery steps, multiple tools are used, as you can see here as well. And then each connection point is a possible point of failure. In this environment, governance and security issues are very common. And in the end, you spend more time managing infrastructure and little time actually working with data. And as I have said a few moments ago, our appetite for data has never been bigger. But connecting data across an organization can be a very difficult task. So from data sources to data consumers. And Snowflake allows you to build a modern data architecture with our leading cloud data platform. We eliminate the complexity, the cost, and the constraints that were present in other approaches. We're available on all the leading cloud providers, as you can see here, and we eliminate all the architectural complexity. So you can run as many workloads with the elasticity, performance, and scale that you require nowadays on Google Cloud, AWS, and Azure. And you might be wondering how we have accomplished all of that. If I can summarize it into one word, is architecture. Our founders, they completely threw out the old enterprise data warehouse architecture to build from scratch a cloud data platform that utilizes all the capabilities of the cloud to the maximum. So it was built from the ground up for the cloud, and our architecture is comprised of layers, as you can see here. So we have the centralized storage for unlimited amount of structured and semi-structured data here. Then on top of that, we have the multi-cluster compute for running multiple workloads without all the resource contention that was common in the other solutions. And we have the cloud services to automate administration, security, and database tasks. And finally, in gray here, you can see the cloud agnostic layer. So to deliver a consistent experience across all the cloud regions and providers. And this unique architecture allows us to offer a wide range of workloads. So right now we have 6 workloads. So data engineering, by leveraging Snowflake's ability to streamline data ingestion and integration, so you can rethink transformation with robust and integrated data pipelines. You can use it as a data lake by using Snowflake as your data lake or alongside an existing one to simplify and accelerate your data lake with one platform. As a data warehouse, of course, with unlimited performance and concurrency, where you can deliver analytics at scale. To streamline data science, so to simplify and drive performance for complex workloads. For building data applications as well, so data applications, they require workhorse at their core, so we can develop apps with fast and scalable analytics that will delight your customers. And finally, for data exchange, so empower your ecosystem to securely collaborate across all data and streamline the data sharing between consumers and providers. And this has been proven by thousands of customers. And they all seen performance, scale, and productivity using our architecture and using the Snowflake Cloud Data Platform. So the next step should be a conversation with you and to help us understand where you would like to go. We have customers such as Capital One, DocuSign, Adobe, Sony, Nielsen, and many others. And finally, one customer example that we have and that uses both Snowflake and Fivetran, the previous speaker here from last week, is Deliveroo. So Snowflake's data platform enables Deliveroo, which delivers food for people in the UK. If you're not based in the UK and you're not familiar with the company, so we enable them to get the data it needs to serve its customers in service of their goal to deliver personalized, data-driven experiences to customers. So you can see here, the scenario that we have is that Deliveroo is a British startup that offers fast and reliable food delivery services. Their main pain points were very common for others as well. So data in different silos, they were not being able to scale as they needed, and then the Monday mayhem, as they said, where all the reports were accessed at once, and it was really, really complicated. And that was impacting their business. They were having incomplete view of the business, inability to answer questions at speed, and endless queues for analysis, and that led to a slow decision making. And now they're one of the main companies here, so they needed to change that. So here is a picture on how Deliveroo raised revenue substantially through insight with what we call the modern data stack. So Fivetran, Snowflake, and Looker. So they now have all of their data in one place for a holistic view, and the questions are answered as quickly as they're asked. So finally, they're being able to bring those better decisions. And besides that, after implementing Snowflake, they saw higher revenue as they were finally now able to personalize the experiences and target the right people. So on the left, you can see Fivetran centralizing the data with little to no manual effort, as they mentioned a few days ago. Then we have Snowflake and Looker on the right side, democratizing the data for the organization. So that's what I wanted to bring to you guys. Thank you very much.
Welcome back, Rafael. Yeah, we've got some questions coming in. Before I put them over to you, I think I can help with a couple of them. In the attachments I mentioned earlier, there's a link to the Snowflake website and link to Snowflake demos. A couple of people asking for demos, a couple of people asking for slides. Do get in touch on social or whatever after the presentation, and we'll send the slides out to you. There's some technical questions that we'll get back to regarding Snowflake as well. That's not a problem. There's one about pricing. I'm guessing it's. Do you want to take that, Rafael? I think you're on mute, by the way. So
yeah, can you hear me?
Yeah, I can hear you. Okay. Yeah. So do you want to take the one on pricing? It's I guess it's how it compares to cloud stuff. Is that something you clear up easy?
Yeah, for sure. So our architecture, we separate data warehousing into 3 layers. So storage, virtual, warehouses, and cloud services. So our pricing is based on the actual usage of those 3 layers and of the serverless features. So we have credits that are used to pay for the consumption, and it's like a unit of measure. So it's consumed only when a customer is using those resources. So for the virtual warehouses, for example, we have a range of sizes, as Mike mentioned. So, and they function as T-shirt sizes. So we have extra small, small, medium, large, extra large, etc. And the size of the virtual warehouse determines how fast queries will run. So when a virtual warehouse is not running, then it does not consume any Snowflake credits. But you can find a lot more information on our website. And if you want to send me an email as well, feel free to contact me.
Yeah, perfect. And some tips or some about migrating Snowflake from on-prem. Is that is that an easy process? Is there some tips you can get? Is there some resources you can provide for that? I think that's a couple of people have queried that.
Sure, that's a very good question. So, I mean, the benefits of the cloud, as I mentioned several times in the presentation, they include all the elasticity and the cost savings and the data security. They're quite easy to attain. So, whether you want to optimize your data architecture or deploy best practices, or let's say leverage partner expertise, we can help. So we have a professional services team that will assist you with all the process. So from onboarding to re-architecting, technical guidance, expert training, and resources. And if I can, I can mention one example that we have, which is McKesson. And so we allowed them to centralize their technology and data management solutions into a core team. And so we removed all the constraints that were, I think it was 60 teams, more or less. They were having several constraints, and we were able to remove all of them in less than 3 months. So they completed their migration from their legacy on-prem environment in 3 months. And we have conversations with them, and they were mentioning that 86% improved load speeds and complex query times increased by 5 times, which is very cool to see in just 1 quarter. So you start a quarter, and then in the next quarter you're 5 times faster and more efficient, and then your teams are not complaining anymore. So that's what's happening with the migration, and more companies are realizing this, and they are finally migrating to the cloud, as it was mentioned before, and we could see that in Mike's presentation as well. So it's a very cool thing to see. It's the process is not hard, and we have teams to support you all the way, and customer examples from all the industries that you can think of.
Perfect. Thank you. You can probably see, Rafael, there's probably more questions than we're going to be able to manage today. So what I'll say is we will commit to get back to everybody after the session. We have your details. We'll send you individual answers about Snowflake specific stuff. I was going to come back to you, Mike, if that's okay, because we did get a lot of questions regarding your first presentation. I'd start with this one. So if we use a data lake for a central point of data storage, then I believe we need to spend some time building a data catalog to be accessible by various tools. What's your thoughts on that as a way forward?
Totally. I mean, you know, to me, one of the key components of a data lake, first of all, is knowing what's in it. And we talk about data lakes like they're central data stores. I don't necessarily agree with that. People also thought data lake meant Hadoop, that also I don't agree with. So, you know, I have customers that have a centralized data lake, which could be cloud storage as a good example. But I also have really large customers where it's just not practical. I mean, they operate, I have one customer operating over 100 countries. It's not practical to turn around and say to them, bring all your data to one data store. You know, it's just not going to happen. I mean, they're just so large, it's not going to happen. Organizationally, it wouldn't happen. So I think so in their case, they've created a logical data mart, which is a group of data stores that are dedicated to ingestion, other data stores that are dedicated to curation, staging, and other data stores which are dedicated to holding just trusted data. So it's an organized set of data stores that they've set up specifically to function as a data lake, even though that it's not physically all in one place. But in either case, whether it's a centralized data lake on cloud storage or whether it's a logical one, a data catalog is fundamentally important because it's important from 2 angles. One is I need it for what I would call information producers, who are the people tasked with taking the raw data and producing what we talked about in the first webinar in the series, which is these trusted data assets. And in that slide that I showed on modern data architecture, the second role of the catalog is to publish the trusted assets so that information consumers can see what data is ready-made, available, that they can then pick up and use and kind of get a a quick start going rather than going back to zero every time and taking raw data all over again and reinventing again and again. So I think a catalog is fundamentally important. There's been, and I think there's no question that the demand for data catalogs is huge. There's probably about 20 plus data catalog products already in the marketplace. So, to give you examples of those, I mean, would be pretty well unfair because people will come, but I could certainly provide a kind of list of them, that people need to, look at to help with automatic discovery of what data they've got available, and also to use to publish the data assets that they create for consumption by both multiple use cases, including data warehousing. So yeah, I think data catalog is a very, very key part of it, as is the data fabric stuff that we talked about in the first webinar. And of course, in this particular case, data warehousing being a user of, if you like, of that data that's coming through into that world for analysis and reporting.
Excellent. Okay, so before I move on to the next question, we've had a couple of people asking for slides, which we said we will send, and someone saying, will there be a link to the earlier part of the presentation? Yes, it's available on demand almost straight away afterwards, so you can just record to the rewind to the beginning and watch the first part of Mike's presentation again if you like. That's not a problem. Also, just a quick one. For anyone who missed the brief intro, this is episode 2 of the Modern Data Architecture series. The data integration one happened a week or so ago. That's on demand. That's one of the attachments on the webinar. The one on data visualization, which is the final part 3, is happening on May the 18th. There's a link to register there. I believe it's just a couple of clicks if you want to do that now to save yourself a little bit of time. And then I will move on to another question for Mike now, though, if that's okay. So
okay.
Other than technology modernization, which I guess is what we've been talking about mostly, what other things need to be done to make data democratization more effective within the enterprise? So, obviously technology is one arm. What else do people need to be thinking about?
Well, I think the first thing that comes to mind is the hardest problem of all, which is how do you organize? And how do you organize people and to succeed? And the problem with that is everybody's got a different agenda across the business, and so the answer, as far as I can see, to succeed with that is you have to start with value and not data. That means, what are you trying to achieve? So is it that you're trying to achieve improving customer experience? Is it that you're trying to reduce risk, like reduce fraud? Is it that you're trying to optimize some specific aspect of your business operations? In which case, that's the value, right? In which case, then it says, okay, if you're trying to reduce fraud, if you're trying to improve customer experience, then what data do I need in order to achieve that? And then who's building it, right? And then I've got to take, what data it is. I've got to prepare and make that data available. I've got to know what reports, what predictive models, all of it, that are needed, because I'm going to end up building a family, if you like, or a group of things that are going to help improve customer experience. And so, which could include a data warehousing, could include multiple predictive models, could include natural language processing in order to do sentiment analytics on inbound, Twitter streams or whatever, or inbound email. And so it's a collection of things. And so to my mind, if you don't start with value, you'll get lots of teams trying to do their own agenda, and they'll all go off in different directions. And it becomes really difficult to hold them back into some kind of organized setup. So for me, the one thing I would do is align with business strategy, a strategically high priority objective, and then choose that, and then say, okay, all the way back to data, what are we building and who's building what bits in order to achieve this business goal? Then you can make it succeed. I think if you just say, well, we've got all this data out here, let's just build a whole bunch of stuff, I mean, the chances of you succeeding are really risky. I mean, it's very high risk that you could fail. But if you start with value and something that's already deemed high priority in a business strategy, which is something set typically at a C-level, then then what you're doing is you are already aligning with a strategic high priority objective within the business. So that for me would be the key thing is it's not just about technology, it's about how do you organize to succeed.
Perfect. And I'm afraid it looks like we've run out of time for today's session. Thank you everybody for so many really, really well put questions. Apologies if I didn't get to ask them. We will definitely come back to you on them. I'd like to say a big thank you to Rafael for his presentation today. Thank you, Rafael, and Mike Ferguson as always. And for now, certainly we'll be bidding you farewell and hope to see you at the next one on Monday. All right. Thanks very much. Bye-bye.